So first is my topic is smart materials on construction material. So first is meaning of smart. What is meaning of smart? S means significant, M measurable, A appropriate, R result oriented, T time oriented. This is smart construction materials. Smart construction materials, which also known as intelligent materials, active materials, and adaptive materials, are those that have the capability to respond to change in their conditions or environment to which they are exposed in useful and controlled manner. Basic on input and output, the smart materials categories are follows: shape memory alloys, magnetostriction materials, piezoelectric materials, electrological fluids, electrochromic materials. So classification of smart materials: type of smart materials: piezoelectric, input deformation and output potential difference, electrostatic, electrostatic input potential difference and output deformation. Third, magnetostrictive, input magnetic field, output deformation. Fourth, thermoelectric, input temperature, output potential difference. Fifth, shape memory alloys, input temperature, output deformation. Sixth, photochromic, input radiation, output color change. Then thermochromic, input temperature, output color change. First, shape memory alloys, which is short name SAMS. Such materials possess the ability to return some previously defined shape or size when subjected to appropriate thermal changes. It has applications in civil engineering, specifically in seismic protection of building. Second, magnetostrictive materials. These materials undergoes mechanical deformation in proportional to the square of the electric field, which refers to the material quality of changing size in response to either on an electrical or magnetic field, and conversely production a voltage when stretched. These materials shows promise in application ranging from pumps and valves to aerospace and wind tunnel. Third, piezoelectric materials. These are the materials which possess capability to produce the voltage when surface strain is introduced. Conversely, the material undergoes deformation when an electric field is applied across it. When integrated into a structure members, it generates an electric field in response to mechanical force. It can diagnose the location and extent of defects, cracks, rust, etc. Fourth, electrological fluids. These are the colloidal suspension that undergoes change in viscosity when subjected to an electric field. Such fields are highly sensitive and respond instantaneously to any change in the applied electric field. It has application in shocks observers. Fifth, electrochromic materials. These materials alter their light transmission properties when voltage is applied. It has applications for the construction of electrochromic device includes optically transparent electrodes, electrolyte layers and device encapsulation. Application of smart materials in construction. First, smart concrete, a composite of carbon fibers and concrete used in smart structures, is capable of sensing minute structure crack flaws. Unlike conventional concrete, the small concrete has a higher potential and enhanced strength. It can be used in electromagnetic shielding and for enhanced electrically conductivity of concrete. Smart materials have application in design of smart building. Smart materials are used for vibration controls, noise mitigation, safety and performance. Third, in construction of smart buildings for environmental control, structural health monitoring. Fourth, smart buildings it used to transform efficiency, comfort, and safety for people and assets. Smart materials reduce the effects of earthquakes. In marine and rail transport applications for strain monitoring using embedded fiber optic sensor. Seventh, the use of smart materials permit the construction of smart bridges, especially cable-stayed bridge with a wider span to avoid the increased susceptibility to various caused by ambient factors such as wind, rain, or traffic. Hence, the structure required a less maintenance and the response of the structure can be monitored. These are used to monitor the civil engineering structures to evaluate their durability. Smart materials in structures used to monitor the integrity of bridges, dams, offshores, oil drilling towers where optic sensor embedded in the structure are utilized to identify the trouble areas. It can be used to rehabilitate the cracking of concrete when superelasticity smart material is used as reinforcement bar. General uses of smart materials. Future scope, smart fabric, smart aircraft, sporting goods, smart dust, reducing vibration, helicopter blades, robotics, medical surgery, security. Future scope of smart material in civil engineering. It includes solving engineering problems with unfeasible efficiency and provides an opportunity for creation of new products that generate revenue. The important features in that they encompass all fields of science and engineering. Show in graphs. Conclusion. Smart materials have properties that react to change in their environment. This means that one of their properties can be changed by an external condition such as temperature, light, pressure or